Alrighty, so here's a really quick video lesson on how to write the chemical formula for an ionic compound using something called the criss-cross method. As you'll see, it's really easy. Okay, so before we get started, let's just check out this first example I have here. So the first example is aluminum oxide. So we're going to have to pull up our handy-dandy periodic table of elements, which you're always going to have to use in chem all the time. Alright, so let's see. So the first formula is aluminum oxide. So they give us the name, and we have to figure out how to write the correct chemical formula for aluminum oxide, which is an ionic compound. Really quick recap on ionic compounds. The reason we know this is ionic is because aluminum is a metal. Whoa. Aluminum is a metal, alright? And oxygen is a nonmetal. So when a metal reacts with a nonmetal, the metal, like aluminum over here, aluminum loses 3 electrons, and we can see that because aluminum winds up getting an oxidation state at the top right of +3. That means that aluminum lost 3 electrons. Actually, it loses those 3 electrons from its valence shell. If you look at the electron configuration, it loses those 3. So where is it losing those electrons to? Well, it's actually losing them to oxygen. So if we look at oxygen right here, oxygen has 6 valence electrons in its electron configuration. It's 2-6. But if you remember, elements want 8 valence electrons for the most part. So oxygen only has 6, so it wants 2 more. Well, check this out. The oxidation state of oxygen is -2. That's because it takes 2 electrons. So here's the problem. Aluminum atoms give away 3 electrons and become an aluminum +3 ion. However, each oxygen atom only can take 2 more electrons and becomes a -2 ion. Let's think about those numbers. +3, -2. That doesn't cancel out to 0. That leaves us with +1. So this is what we have to do. We're going to write down the ion and its oxidation state for aluminum. Then we're going to write down the ion for an oxygen negative ion, so oxygen -2. And then we're going to crisscross those numbers. So check this. Now the whole purpose of this is we want the electrical charges to cancel out to 0. So watch my first example right here. Hey, sorry if there was just a mistake in the video. Let's try that again. So here's the first example, aluminum oxide again. So there's aluminum +3, the oxygen ion, oxygen -2. You take the charge, which is 3, and you crisscross over to the oxygen. So you need 3 oxygens, and the oxygen is -2. So you cross the 2, ignore the charge sign, ignore the plus and minus, you just take the number. So you take the 2 and crisscross it over, and that means you need 2 aluminum ions. So the final formula is 2 aluminum ions for every 3 oxygen ions. So the chemical formula for aluminum oxide is Al2O3. 2 aluminums, 3 oxygens. Watch one more time. So aluminum +3, oxygen -2. So we have 2 ions. Crisscross the 3 and the 2. So you need 3 oxygen ions and 2 aluminum ions. And we wind up with Al2O3. Okay, so here's a second example of using the criss-cross method to create the correct chemical formula for an ionic compound. Check the second example, iron 3 chloride. Okay, so iron is a little bit trickier because it is a transition metal, meaning that it loses different amounts of electrons in different chemical reactions. So sometimes iron can lose 2 electrons, sometimes it loses 3. So in the chemical name, if you look, there's a Roman numeral 3, iron 3 chloride. That doesn't mean that there's 3 iron ions. That means that the iron ions have a +3 charge. So that's what the iron 3 chloride means. So let's check this out really quick. Periodic table. Let's find iron, and there's iron. So if you look, iron has 2 possible oxidation states. Sometimes iron becomes +2, sometimes it becomes +3. So in the name that's given to us, we see that this iron is iron +3. Okay, so iron is iron +3. Cool. And it's bonded to chloride. So here's the tricky thing here. On the periodic table, they give us chlorine as having oxidation states of -1, +1, +5, +7. Here's the deal. With the nonmetals, for the most part, ignore all those positive oxidation states because that usually doesn't happen. Nonmetals usually take electrons, meaning they gain extra electrons, which means that they become negative ions. So chloride, 99.9% of the time, chloride means that you have a chloride -1 ion. So the iron is iron +3, and the chlorine is a chloride -1 ion. So check out how I work to this example. So iron +3, chloride -1. So crisscross. You need 3 chloride ions and 1 iron ion. But just like in algebra, we don't put 1x. You're not going to put iron 1. That's unnecessary. So you just put the 1 iron ion, Fe, and 3 chloride ions. And that cancels out all of the electrical charges to 0. Watch one more time. There's the iron +3 ion, and there's chloride -1. Take the electrical charges, swap them. Now you have iron 3 chloride. And again, you don't need to put 1 for the iron, just like you don't put 1x or 1y in algebra. Alright, so one last example on how to use the crisscross method. This one is a little bit more annoying, but this is the hardest thing that you will see. Okay, so look at the name of this last chemical compound. It says vanadium, and that's Roman numeral 5. So vanadium 5 carbonate. Oh, okay. No sweat. First, let's find vanadium on the periodic table. Vanadium. It's fun to say. All right. Vanadium. Whoa. Okay. So vanadium has 4 possible oxidation states. Don't forget that any of these metals that has many oxidation states is called a transition metal. Transition means change. So these metals can change how many electrons they give away. So vanadium can be vanadium +2, vanadium +3, vanadium +4, or vanadium +5 ions. Let's check the chemical name given to us again. Vanadium, Roman numeral 5, carbonate. Okay. That doesn't mean there's 5 vanadiums. That means that the vanadium is vanadium +5, which we see right here on the periodic table. Vanadium +5. Okay. What is it bonded to? Vanadium +5, so that's the positive ion. So the negative ion is carbonate. Carbonate? That's not an element. That's a bunch of elements. So we have to go to table E, polyatomic ions. So let's go there really quickly. Okay, table E, table E. Aha. Okay, let's zoom out. Okay. Reference table E, selected polyatomic ions. Crazy word, don't forget what it means. Poly means many, many what? It says polyatomic, that means many atoms. And these are all ions because they have electrical charges. So that's pretty easy. These are ions, they have an electric charge, either plus or minus, positive or negative. And they're made up of more than one atom. So let's find carbonate. Carbonate, where are you? Ah, over here. Carbonate is 1 carbon atom, 3 oxygen atoms, and the electrical charge of that whole molecule there is -2. So it's called carbonate. That's what's in your soda. That's why your soda is fizzy. Okay, so here's the important thing. Carbonate is CO3, but the electrical charge is -2. Things get a little messy here because you see how carbonate is made up of 4 atoms, 1 carbon, 3 oxygens? Well, if you start throwing numbers next to this O3 without parentheses, it's going to look like you wrote 31 or 35 or whatever. So we have to put parentheses around this to make it neat. You'll see what I mean right now. So check out this example. Okay? So in this example, we have vanadium 5 carbonate. Now watch what I do. So there's vanadium 5. Now here's the carbonate. See how I put parentheses around carbonate? It's to make it look neater. So now swap the charges, crisscross them. And the chemical formula for vanadium carbonate is V2. Oh, sorry. Vanadium 5. We have to say that. Vanadium 5 carbonate is V2, CO3 in parentheses, 5. I'm going to play it again. The reason why we need parentheses is because what would happen if we put the 5 next to the carbonate, so CO3, and we put the 5 right next to it? It's going to look like we put CO and then 35. It's going to look messy. Try it on your paper right now if you don't believe me. Okay? So one more time. You're going to draw the vanadium 5, so vanadium plus 5, and then the carbonate with its charge, which is -2, but put parentheses around the carbonate. That's because it says CO3. Okay? We're just putting parentheses to make things look nice and neat. One more time, watch. Vanadium plus 5, carbonate -2, parentheses, now crisscross. We need 5 carbonates and 2 vanadium plus 5s. So that's V2, parentheses, CO3, and how many of those do we need? 5. Okay, make sure you got the parentheses for the polyatomic ion. Alrighty, good luck with any other ones you try. No sweat, you should be fine.